Let's take a few minutes and go through the most frequently missed questions on Part C of the multiple choice questions from the Unit 5 Personal Progress Check. These are the results for first period and for fifth period. Those classes look very similar in terms of how they did. In third period had one group involving sampling distributions for single sample means and another group for differences in sample means that we should probably look at. Those same two groups were problematic for fourth period, along with a couple more. So there's a total of 8 questions there that I want to go over here, and I've tried to highlight some things so that this won't take too long, but it will focus on some ideas regarding the sampling distribution for a sample mean or for the difference between two sample means. This is material that we will be using later this week. So going in order, then, the first 4 questions are about the sampling distributions for single sample means. So here we're working with a population that is skewed, but notice we're using samples of size 100, so that's why the sampling distribution for the sample mean is still approximately normal. These were the most commonly missed questions. The sampling distribution for the sample mean will not be skewed right. Yes, the population is right skewed, but because of the central limit theorem applying here, this is a sample size well past 30. So the sample means will be approximately normal. The other thing, the sample means will not have the same standard deviation as the population. For sample means, their standard deviation is the standard deviation of the population, the 0.7, but then you have to divide by the square root of 100. That formula is on your AP formula sheet. This question, which of the following is true about the sampling distributions of the sample means for these two different sample sizes? So notice one sample is of size 5, the other is of size 85, but we are sampling from a population that is already approximately normal. So regardless of the sample size, both distributions are approximately normal. Regardless of the sample size, whether you're using a sample of size 5 or size 85, the population mean will still be at the center of those sampling distributions because the sample mean is an unbiased estimator of the population mean. And the standard deviation for samples of size 5 is going to be larger. The standard deviation for a sample of size 85, that's going to be smaller because you're dividing by the square root of 85. Next question. This question is really just about interpreting what this probability statement means. So part E is the correct answer. For a random sample of 50 customer wait times, the probability that the sample mean will be greater than 25. So this is the probability. This is a sample mean wait time is greater than 25. That probability is about 10%. So these were the most commonly missed wrong answers. A is wrong because this is a statement about total wait time, but the probability we care about is about the probability of an average wait time. Part C is also wrong because this is a statement about a randomly selected customer. This probability statement, this event has nothing to do with a single customer. It has to do with the average of 50 customers. So last question, I believe, about the distribution for a single sample mean. So I think this question is a little bit on the tricky side because you have to believe when you read this that 150 is the truth. The question states, a sports magazine reports that the mean number of hot dogs sold by hot dog vendors at a certain sporting event is equal to 150. So we are believing that that 150 is the truth, and we are asked about the sampling distribution of the sample mean. We're asked about which of these statements is true about that sampling distribution, and these are really statements about the mean. So what's true about the sampling distribution? The mean of the sampling distribution of the sample mean is 150. That's the correct answer because we're supposed to believe that what the sports magazine has reported is the truth. So the most commonly chosen wrong answers, D, the sample mean of the sampling distribution. The mean of the sampling distribution of the sample mean is 140. The 140 is the mean from one random sample. It is not the truth in the population. B is also wrong. B says for all random samples of 50 hot dog vendors, the sample mean for all of the random samples will be the same, will be 140. That's definitely not true. When you take a sample mean from a different sample of vendors, you're very likely to get a different number of hot dogs that have been sold on average. So the remaining 4 questions are about the sampling distribution for the difference between 2 sample means. And here we are interested in the average, the mean for the distribution of the differences between the 2 sample means. Don't work too hard because we know the first population has an average spinning time of 2.7 minutes. The other population has an average of 4.2 minutes. So to calculate the answer, you just have to take the 2 means from the 2 populations and subtract them, and you're done. So the most commonly chosen wrong answer was D, where it looked like people were trying to take the sample mean from the first population and divide by how many observations there were. Here's the mean from the second population and divide by how many observations there were out of that population. But there is no reason to try to create means by dividing by how many observations you have, because you already know the true mean for each of those populations. So if you want the true difference, all you have to do is take their 2 true means and subtract. This is also a very tricky question. It's not a difficult question, but you have to look carefully at what's been given to you. So notice, for a single roll of a die, you are given the mean. The average of the number that is landing face up is 3.5. Understand the variance, which is the square of the standard deviation, is 2.92. So we are looking then at the standard deviation for the difference between the sample means, where I believe the first sample mean is the average of the numbers that land face up from the first 5 rolls, and the second is the average from the last 10 rolls. So understand that explains the denominator in the correct answer and in the most commonly chosen wrong answer. So here we're looking at 5 trials in the first mean, and here we're looking at 10 in the second mean. But understand, if you look at the AP formula sheet, what you are doing is taking the square of the standard deviation, dividing by the sample size, and then under independence, you can add those together and take the square root. Well, understand D is wrong because what you want to do is square the standard deviation. This 2.92, though, is not the standard deviation. It has already been squared. That's called the variance. So we have answer C being correct because this is already the square of the standard deviation. I don't need to do the squaring. The squaring has already been done. The square of the standard deviation, that term is called the variance. So next question, we have 2 different sample sizes, and we don't know anything about the age of the pennies and the age of the quarters. I don't know anything about the distributions of the population ages of those pennies and quarters. So I have 25 pennies and 35 quarters. So the correct answer here regarding the normality condition is that no, the conditions for normality have not been met because the sample size for pennies is not large enough. I would want that sample size to exceed 30 or more. Here, the most commonly chosen wrong answer was this. It said, yes, the normality conditions are met because both samples are large enough. That's not true. The normality condition for a sample mean, for its distribution to be approximately normal, if the population's distribution is unknown, or if the population is not normal, we need large samples of at least 30 or more. This question here, the most important information is to recognize that we are looking at 10 randomly selected town council meetings, 10 randomly selected arts council meetings, and we are looking at the time for those, the length of time that those 10 randomly selected meetings took. And we're interested in why the sampling distribution here, the distribution between the difference between the sample means for the town council and the sample means for the arts council meetings, why can those be modeled with an approximately normal distribution? And the key is up here. The key is up here because the meeting times are approximately normal for both the town council and for the arts council. So the bottom line is the correct answer is the population distributions are approximately normal. The most commonly chosen wrong answer, and I understand why this was chosen, B, people said that both sample sizes are large enough to satisfy the normality condition. Well, notice those sample sizes are not large enough to satisfy the normality condition, because if the populations were not normal, the normality condition would require sample sizes that exceed 30. So, but we don't have to worry about that condition. The truth is, we don't even have to check a normality condition because both the populations are already approximately normal. So the difference of the sample means is also approximately normal.